Good morning. Today we'll discuss haloalkanes and haloarenes. Haloalkanes means when the hydrogen of alkane is substituted by halogen and when the hydrogen of aromatic ring is substituted by halogen. We call them haloalkanes and haloarenes. In this chapter, we will take about some reactions: nucleophilic substitution, electrophilic substitution, elimination reaction, carbide-amine reaction, Riemann-Tiemann, Wurtz and Wurtz-Furtik reaction. Now we start nucleophilic substitution. In this reaction, a stronger nucleophile replaces the weaker nucleophile, just like halide ion. In this case, so we are taking some examples. When we react haloalkane Rx plus OH-. This is a stronger nucleophile, so haloalkane is converted into alcohol by this process. Similarly, if we substitute halide ion with ether group, now we react haloalkane with sodium salt of alcohol. Then due to this we can get ether. So there are so many reactions in which stronger nucleophile replaces halide ion. Now we start some nucleophilic substitution reactions. So there is a first substitution reaction is Sn2. Sn2 means nucleophilic substitution in second order. This is specially shown by 3-degree alkyl halides. Why? Because in this case, when there is 3-degree alkyl halide shows Sn2 mechanism, then there is a steric hindrance. So due to this, 3-degree alkyl halide does not show Sn2 mechanism. It is mainly shown by primary alkyl halide, because in this case a stronger nucleophile attacks from the back side of carbon, which is positively charged due to the polarity between carbon and halogen. So when it attacks from the back side, then after that, if the nucleophile makes stronger bond with positive carbon, then halide ion removes and then stronger nucleophile easily take the position. Just like this, OH ion attacks from the back side, and in this process, when nucleophile change its position, this configuration is called inversion. Now we start Sn1. It is mainly shown by 3-degree alkyl halides. It is completed in 2 steps. It is a first order, because in this case, when 3-degree alkyl halide is reacted with stronger nucleophile substance, in that case, first of all, the alkyl halide is broken to give 3-degree carbocation, because 3-degree carbocation is highly stable. So in first step, 3-degree carbocation is formed, and after that strong nucleophile attacks on carbocation. But second step is faster, so rate determining step is a slow step. This is a first step. Now we come to retention. Retention means the position of stronger nucleophile is not changed after the removal of halide ion. So we can say that Sn1 is a retention mechanism. Now we start. This is the mechanism of Sn1. First of all broken, then slow step, and then attacks. This is the fast step. Then now we get stronger compound. So this is the first order reaction. Now we come to some chemistry of Grignard reagent. Grignard reagent is RMgX. When it is heated with water, or it is also reacted in moisture, it gives hydrocarbon. Similarly, it reacts with alcohol, it also converted into hydrocarbons. When it reacts with carbon dioxide, it forms carboxylic acid. When it reacts with formaldehyde, it gives primary alcohol. Then CH3CHO, it gives secondary alcohol. And when it reacts with ketone, it gives tertiary alcohol. Similarly, when it reacts with HCN, it forms aldehydes. When it reacts with RCN, then it gives ketones. Now we start some reaction of alkyl halide. These are the nucleophilic substitution reaction. In this case, haloalkane is highly polar. So when it is heated with aqueous medium of NaOH, OH ion becomes stronger nucleophile, so it replaces halide ion and to form alcohols. Same as when alkyl halide is heated with sodium salt of alcohol, then we get ether. This reaction is also called as Williamson synthesis. When it reacts with sodium cyanide or potassium cyanide, we get alkyl cyanides, or we can say nitrides. When we react with sodium salt of alkynes, then we get higher alkyne by this process. Similarly, if it is reacted with nitrite, then potassium nitrite, then we get alkyl nitrite, or if it reacts with silver nitrite, we get nitroalkase. Similarly, if it reacts with silver cyanide, it gives isocyanate. Why? Because Cn minus in case of KCN and ONO minus in case of potassium nitride, these two are ambiguous nucleophiles, so the reaction can be taken from any other site. When haloalkane reacts with chlorine, because haloalkanes are ortho and para directing, so when they show substitution reactions, then we get ortho and para compounds. There is a Friedrich-Krafft reaction, alkylation, acylation, these all. Now we start elimination reaction. In elimination reaction, when alkyl halide is heated with alcoholic medium of NaOH or KOH, the alkenes are formed, elimination reaction take place. Why it occurs? Because in alcoholic medium, alkoxide ion and OH ion both are there. And alkoxide ion is a stronger base than OH ion, so it shows elimination reaction, and what is formed? Alkene is formed. It was given by Sergev rule. According to the Sergev rule, elimination occurs in such a way that double bonded carbons are highly alkylated. In this case, when we react CH3, CH2, CHBr, CH3, what we get? CH3, CH double bond CH, single bond CH. It is a highly substituted alkene. Now we start some haloform reactions. Haloform reaction is also called as iodoform test, and it is mainly shown by those compounds which have methyl keto group. For example, when CH3, CH2OH react with NaOH and I2, we get CHI3, because NaOH and I2 gives NaOI, which is an oxidizing agent. So first of all, CH3, CH2OH is converted into CH3, CHO. It means it has methyl keto group. Secondly, in case of secondary alcohol, it is first converted into ketone and then react with NaOH and I2, and then we get yellow precipitate of CHI3. And the ketones having CO at second position also shows iodoform test. Now we start Wurtz reaction. In Wurtz reaction, haloalkanes react with sodium salt, then we get the symmetrical alkanes having double carbon atoms as compared to alkyl halide. Now we take Wurtz-Fittig. In Wurtz-Fittig, we use alkyl halide and aryl halide react with sodium in the presence of dry ether, then we get alkyl benzene. Now we take diazonium salt. What is the diazonium salt? Diazonium salt is C6H5N2 plus X minus. In this case, there is the formation of benzene diazonium salt is by the reaction of aniline and NaNO2 and HCl at 0 to 5 degrees Celsius, then we get diazonium salt. Diazonium salt is used to make so many compounds. The formation of diazonium salt is called diazotization. For example, when diazonium salt is treated with H3PO2, we get benzene. With alcohol, we get also benzene. CuCl, HCl, we get chlorobenzene. CuBr, HBr, we get bromobenzene. These two reactions are called Sandeyer's process. With CuCN, we get cyanides. With HNO2, we get nitrobenzene. And with NaNO2 and HBF4, we get fluorobenzene. This is a special type of process which is used for the formation of fluorobenzene. Thank you.